Hi guys, it's going to be the first video of the year in physics class, and it's going to be a little bit different year for all of us. For you, you're just going to be watching videos and to try to figure out what's going on, and I will be just talking towards the computer. Alright, but I hope that we are going to leave it behind as soon as possible, and then we're going to continue in our classes, but as what we have right now, we are going to continue like this. And I'll try to keep my videos short, but sometimes they're going to be a little bit long, but that's what we have at this point. Alright, let's get started. Study of physics. So what does physics study, or what is physics first of all? So in this picture you might be able to see different images, and they might seem random, but these are all about physics basically. And physics is a branch of science, of course, and it's not a random thing, and it studies matter. So what is matter? Anything that has basically mass and volume is going to be considered as matter. So basically physics studies their behaviors in space and time. All right, and we are going to have 6 different areas of physics, and let's try to figure out those, and let's talk about those areas. So at this point you can just pause the video and then try to just look at the picture and then try to understand and try to figure out, make some observation and then try to guess those areas of physics. Alright, so I'll give you a couple of seconds over here, so just look at the picture and try to guess those areas. Alright, so first of all you have sun over here. So from sun you can think about light rays, as you can see, or you can think about heat. So we have a lens over here. Light rays are basically going in a different direction. You have look like a mirror over here, and then light rays are reflecting. So you have something over here oscillating. You have water droplets, a wave, circuit, computer. So water pool and ripples, and you have a falling apple over here, rolling marble, a person standing on the wall, all of those diagrams. So these are all basically related with physics. But like I said, we're going to have 6 different areas, and the first area that we are going to have within physics is mechanics. So mechanics basically studies motion and its causes. So anything that is moving is going to be the part of study of mechanics. So, and it basically explains why things move, how they move, and or if they're at rest, why are they at rest. Alright, so that's mechanics, motion, and its causes. So the next area in physics is thermodynamics. So you can also think about thermodynamics from chemistry. So in chemistry, you basically, once you think about thermodynamics, 2 things should probably come to your mind: heat and temperature. So anything related with heat and temperature, that's going to be the study of thermodynamics. And by the way, you are going to have links on those titles. So once you click on those links, you're going to be able to see what they're about. So you're going to see short videos about what they are. So in thermodynamics as well, once you click on the video, so pause my video, click on the link, watch the video, then you can move on. Alright, vibration and waves. So what does that study? So we have basically ripples over here. So it studies specific, not just any types, but specific types of repeating motion. So those water droplets are basically creating 3 different it touches water at 3 different points, and all of those water when it hits, it basically create those circles, and as you can see, they are all circles. It's a specific type of repeating or repetitive motion. Alright, optics, again, you can see the link over here. Optics studies light and mirrors. So once we have a rainbow, it basically explains why it happens or how it happens. So those colors, are they random color, or the shape that we have, why is it arc shape? So optics basically explains all of those. Electromagnetism, so it's basically 2 words together, electromagnetism, so electricity and magnetism. So that's what it studies. So compasses is working with the magnetic field of Earth, and all of those lightnings are basically part of electricity. And light is a mystery for most of the physicists still, and electromagnetism also studies light. All right, quantum mechanics. So what does quantum mechanics study? In daily life, sometimes people use quantum. I don't know what they refer by quantum, but I feel like they are just trying to mean like something complex. Yes, quantum is complex, but quantum is about size. Anything that gets smaller, like in an atomic level, even actually smaller than atomic level, then the mechanics, the behavior of those objects are changing. So for example, we cannot just disappear at one point and then appear at somewhere else, but electrons or some tinier particles can do that. So their behaviors are different than what we can see. So that's why quantum mechanics need to be a different study area of physics. And again, you can click on all of the links and then watch the videos about those different areas of physics. All right, so after those 6 areas, then we're going to talk about units and SI system. So SI basically System International, or International System of Units, but the original name is coming from French. So, and in French it's System International, something like this. So that's why it's called SI unit system. So why do we use SI unit system? So all scientists are basically making some measurements, some research, but they need to basically talk the same language. So if they all talk in different language, then they're not going to understand each other. So for all of their measurement, they need to have a reference. They need to have a standard. So that's why all of the nations came together and then agreed on some measurement systems in the world, and that basically system is known as International System of Units. And we basically have 7 unique quantities, and those are the only measurements that we have as base. Anything that we know of is basically coming from those 7 units. For example, if you're talking about speed, speed is meters per second. So meters per second. So everything, any unit besides those are going to be driven from those 7 units. So we're going to be talking about the first 3 for a while, for like 6-7 chapters, but after that we're going to be moving on to the next units. Alright, so length standards in international systems. What is the length standard? What measurement do we use to measure the length? We use meters in SI system, not inch, not miles, not kilometers, it's meters. And what is a reference for 1 meters? That's kind of interesting, but scientists needed to have an unique measurement method that is okay for everybody in the universe. So that's why they are trying to take some constant as a reference, and light travels at a constant speed all over the world. So it's better to take this as a reference. So how did they define 1 meters? For example, we have a light. So once you turn on the light, it's going to start to travel. It's basically going so fast that we can't really see that it's moving, but it actually moves. So once that stupid number of times passes, that much of a second, it's basically 1 divided by whatever that number is. When that time passes, then what's going to happen? The light is going to travel some distance. So that distance is basically known as 1 meter. So that's how they standardized the length, 1 meter in science. All right, what about mass? So what do we use to measure the mass? We basically use kilograms. All right, and what is kilogram? And that's kind of a recent change. It just happened 2 years ago. Until like 2 years ago, 2018, 1 kilogram reference was an object. It was a sphere, it's a not a sphere, it's a cylinder. Well, two types actually. Platinum, iridium. So that was basically one cylinder or spherical object that was kept in Paris. And that was basically the reference for 1 kilogram. What is 1 kilogram? They were basically showing that particular object. But it was only in Paris. And the other problem is radioactive decay. So as time passes, things decays. So, and yes, platinum iridium was a very special material that didn't really decay too much. But even that really tiny decay was basically a problematic. 1,000 years later, that 1 kilogram would not be the same 1 kilogram. So they decided to change it and basically connect it to another constant, and they decided to connect it to Planck constant. Well, it's kind of a complex equation, so I didn't really need to use the equation, but it's basically depending on Planck constant. So it's also the same for everybody. All right, what about time standard? So time is measured in second, but what is 1 second? Now, what is the reference of 1 second? That's also a crazy method. So this time they basically choose a cesium-133 atom. All right, so this is an atom, and the same atom everywhere in the world. So once this guy vibrates that many times, or that many times, all right, so that's up and down motion. So when it makes that many vibration, it just counts for 1 second. All right, so this stupid machine, that's what it does. It counts for that many vibrations. And when it makes that many vibration, then it counts for 1 second. That's the standard of 1 second. All right, so these are the three main standards that we are going to talk about for, like I said, a couple of units. All right, so what is, like, how do we add or subtract the units? You only have one standard or one rule for this. For example, if you would like to add 2 kilograms in 5 seconds, is it possible to do so? Well, it doesn't make sense, right? Because to be able to add or subtract two quantities, the units, they must have the same unit. All right, so that's why 2 kilograms in 5 seconds cannot be added or subtracted. You need to have 2 kilograms and 5 kilograms, or 2 seconds and 5 seconds, or two same units to be able to add and subtract them. All right, so that's going to be a video about the size and how macro scale and micro scale basically. So that's an interesting video, 3 minutes video. So watch the video first, and it's going to basically show you how big the universe is or how small the particles are. And then we are going to have certain names for those sizes. So, for example, if you would like to talk about centimeters, so that centi, or that's what we know mostly, but it's not just centimeters. Centi is just the prefix for, and centi represents 10 to the power of -2 units, 2 power. And milliseconds or millimeters, so that's the power of -3. So after this, each unit is going to decrease by 3. So for -6 power, we're going to use micro. And this is a weird letter. We call it mu. And next prefix is going to be nano. That's power of -9. And it's going to go on like this. So it's pico, femto, auto. And these are going to basically decrease by thousands, because there are like 3 different 3 numbers. That means like 3 zeros, and 3 0 means 1,000 times. And if you like to go in a positive direction, so we have deci and deca, but we are not going to be using those deci and deca, but we are going to be starting to use from kilo. So kilogram or kilometers. So that's something that you're familiar with. So 3 is basically the unit, or the prefix for or 1,000 technically is basically kilo. Alright, so if you add or multiply this with another 1,000, that's going to become 10 to the power of 6. So in this case, it's going to be represented with mega. And if you multiply with another 1,000, and then it's going to be giga or giga. And another 1,000 will be tera, peta, and exa. So this part actually, if you guys are familiar with computer terms, kilobyte, megabyte, gigabyte, terabyte. So basically these are increasing by thousands. Alright, so these are prefixes for those numbers. Alright, so any unit can be, or those numbers or those letters can be put in front of any unit. Alright, so common base units. So we're going to have base units. So those units are basically second, gram, liter, meter, joule. All of those are common, like most used units, and we call them base units. And base units, they don't have, well, they have power, but the power for those are 0. Alright, so if you just have, let's say, 1 kilogram is just 1. Alright, so the power for 10 is 0, and 10 to the power of 0 is just 1. Whoopsie, I put the question first. Anyways. Alright, so rewrite the measurement of 23 billion, I believe, 400 million, right? Yes, 400 billion. Meters by using powers of 10. What is the name of the prefix and what's its abbreviation? Well, like I said, prefixes are going by powers of 3. So they change by 3 or times 1,000. So once you look at it, you have 3 zeros here. So 3, another 3, 6. So we can go by another 2, but that's 8. So we don't really have specific name for 8 zeros, but we have specific name for 9 zeros. So it's better to write it as 23.4 times 10 to the power of 9 meters. And now we can basically represent this 10 to the power of 9 with a letter. And once we go to the chart, we will see that 10 to the power of 9 is represented with giga. So this 23.4 times 10 to the power of 9 can be written as 23.4 gigameters, or capital GM. Alright, so that's how we do it. Alright, the next one is going to be negative powers, because this time we are not going in a positive direction, but we are basically making it smaller and smaller. So now we need to count how many zeros we have. So 1, 2, 3, 4, 5. 5 0, but we don't have a special name for 5. So that's why we're going to go one more, and that's going to be 6. And we have a special letter for 6. So that's why we are going to go with 1.2 times 10 to the power of 6. But since it's getting smaller and smaller, it's going to be negative 6. So it's 1.2 times 10 to the power of negative 6 joules. And once you check the unit or the name for negative 6, it is micro. Then the answer will be 1.2 microjoules, or mu joules. Alright, so basically that is the end of the first lecture. Thank you for listening.